Hello everyone, my name is Chris Cundy. I'm editor at Insurance CRM, and welcome to our webinar on mastering data science projects for insurers, held in association with Crowe. We have a fascinating discussion lined up for you that will describe how insurers can use data science techniques to improve their business performance and ensure these kind of projects are successful. Over the next hour, our four speakers will talk you through the most important elements of data science projects. The last 15 minutes of that will be a question and answer session. I will introduce our panel now in the order in which they will be speaking. First off is Daniel Bruce. Daniel is a partner at Crowe, where he specializes in helping clients integrate risk and capital management frameworks and with projects to facilitate better business decisions. Daniel will be giving us an overview of today's webinar. Lloyd Richards is a senior manager at Crowe, where he specializes in helping clients with enterprise risk management, strategy development, and many other actuarial related activities. Lloyd will talk us through the common business challenges and data management issues in data science projects. Danny Saksenberg is co-founder and chief AI officer at Emerge, a consultancy that helps firms across many industries build solutions that use artificial intelligence to create value from data. Danny will explain the insights that data science can give to the insurance industry. Our fourth presenter is Andy Lyon, partner and co-founder of Blacklight Advisory. He's an expert in helping leaders manage transformations within their organizations. And is going to describe how we can actually ensure the new tools and techniques we develop in data science projects are used by employees and not left on the shelf. Our speakers have been chosen completely at random. Crowe has previously collaborated with Emerge and Blacklight on numerous projects. And that's a fact that reinforces one of the key messages to come from today's webinar, that a successful project requires collaboration from people with a wide set of skills and perspectives. As I mentioned, you will be able to ask questions. Please simply type them into the questions tab on your control panel at any time during the webinar. And we will do our best to answer them towards the end of the session. Before I hand over to Daniel, just two more things I should mention. This webinar is being recorded, so you or your colleagues can listen again on demand for a couple of months after today's broadcast. The second thing is that there are other resources you can access from today's webinar: a complete slide deck and a handout that summarizes how Crowe can help with your data science projects. If you click on the Handouts tab on your control panel, you can download those now. Okay, well, that's it from me. I'm going to hand over to Daniel now to introduce the webinar. Thank you, Daniel.
Thank you very much, Chris. This webinar is entitled Mastering Data Science for Projects for Insurers, and there is a healthy emphasis on both the mastering and projects aspects of what we will cover, in addition to data science. Next slide, please. So there has been a lot of focus on data over recent years, both in terms of GDPR and data being seen as an asset. And machine learning is regularly heralded as the solution to many of the world's problems. Unfortunately, we all too often have observed that machine learning projects within insurance companies have not been deemed successful, which in the majority of cases is a wasted opportunity and makes companies reluctant to invest in further innovation activities. So this webinar is all about helping to maximize the chances of success. Some of the common pitfalls we sometimes observe are, well, firstly, not being able to understand the various components of a successful project. A common view is it's all too complicated and we wouldn't know where to start. Another issue is not involving the right people at the right time, hampering timely and effective decision making. Another is not joining up the dots between different functional areas of the business. For example, where and when to involve the board, IT skills, first line teams, and people skills. Another common problem is not clearly setting success criteria, and sometimes recognizing when to stop a project. After all, innovation can't always be successful. And finally, thinking that the project is done when the data science part is finished. Often there's much to do to ensure that the value from the data science activity is fully realized in an efficient manner. We think it's helpful to consider these sorts of projects in the context of a journey that the underlying data goes from from its raw state all the way through to successfully meeting the business objective of the project. And we like to think of this as the data journey. Next slide, please. Oh, I feel like Chris Whitty. Great. So yeah, this is the data journey, and a successful project starts with an identification stage. And this is where business challenges and opportunities are identified, and potentially where machine learning is thought to be a solution. And this is where the objectives of the project are set, the data is sourced, and the full range of stakeholders is identified. The preparation stage includes defining success criteria, assembling the team, which may be entirely in-house or may include external third parties, ensuring appropriate governance is in place, and developing a plan. Project governance arrangements in particular need to be thought through very carefully to ensure the project remains on track and involves the right stakeholders at the right time without stifling innovation. Ultimately, that's what we want to try and avoid, is stifling innovation. So there's clearly a balance that needs to be struck. The insights stage is, funny enough, where insights are gained through data science, often through tools such as machine learning. We've found that a proof of value exercise can often be really valuable to help understand the data, the insights that may be possible, and to help gain business buy-in to progression towards a full project. This insight stage is arguably the most fun part, but is unlikely to be a success without the other stages of the data journey. The action stage is where decisions are made about if and how to proceed, what people, process, and technology implications there may be, and how to solve them. And last but certainly not least is the embedding stage, which looks at ensuring people, process, and system changes are embedded. We've typically found that this can often be the hardest part, because it likely requires consideration of company culture and may require some changes to the operating model. And finally, you can see that governance, culture, and ethics permeates its way throughout the journey. And this is really important to help alleviate and deal with stakeholder concerns, get input from the right people at the right time, to regularly think about the impact on the organisation, and also to ensure that important topics such as ethical issues and data privacy are properly considered. My co-presenters today will each speak in more detail to aspects of this data journey, broadly separated into the bit before the data science part, identify and prepare, the data science part itself, insight, which Danny will cover, including some case studies, and then the end phases of the project, where the results and outputs from the data science work are embedded into the business, action, and embed, which Andy will cover. As Chris mentioned, Crowe has collaborated with Emerge and Blacklight on a number of client projects, so we are used to linking up the various parts of the data journey to deliver an integrated approach with successful outcomes. So, to get the ball rolling further with identify and prepare, I'd like to hand over to my colleague Lloyd Richards, who is a senior manager at Crowe, and he will cover some of the business challenges that can be solved with a data science project, and also cover some of the data issues to think about. Lloyd.
Thanks very much, Daniel. Next slide, please. So Daniel introduced our data journey, and I'm going to start by taking you on the first two stops of that journey, which we can think about as the bits before the data. And I'll talk about these bits before the data in the context of some common business challenges. Now, really, when it comes to data, there are two main challenges, which are very human challenges and two sides of the same coin. There's excitement and there is fear. The excitement side of the coin comes from having lots of data and shiny new algorithms to play with and receiving management support to go away and do data without having any real thinking or strategy behind what it is that you're trying to achieve. Now, this focus on the tangible parts of the projects, the data and the outcomes themselves, is really great, but focusing just on those areas which are most glamorous without proper planning can cause problems. It's often quite easy to obtain data and start modeling using these new exciting algorithms, but doing so without fully understanding the data and crucially the business needs leads to insights coming out that aren't really useful to you as a company and ultimately some wasted time. The flip side of the excitement coin is fear. Again, a very understandable emotion in the context of data science where techniques are new. Many senior decision makers can feel they lack the formal training. New is always scary, especially where specialist knowledge is needed, and the idea of setting up a specialist data science team can be daunting. The result of fear is, of course, inaction and being left behind by your peers. So two opposing emotions, both very understandable, both leading to mistakes in their own way. And the way to overcome them is to spend some time before going anywhere near the data, understanding the objectives and challenges of the work we're looking at. Now, we've worked on a number of projects and have found that those with the strongest consideration of business objectives up front are invariably the most effective. So the first step really is to think about what you want to do with your data. Potential use cases you could consider, and some of which we've worked on, might include focusing sales efforts to increase conversion rates by using a neural network to spot hidden patterns in existing data sets in order to identify potential customers with characteristics that are most like existing customers. A similar methodology could be applied to predict and therefore reduce lapses or anything else that you're trying to identify earlier on through a pattern spotting. Other objectives might be increasing the accuracy of pricing models, reducing underwriting costs by automating the most generic parts of the process, performing detailed customer behavior analytics to give insight into how engaged customers are with their policy, and understanding the price elasticity of renewals. Separately, the organizational obstacles and challenges can be understood by defining a robust data journey. This isn't designed to quash the excitement around data science, or worse, to stifle innovation, but to hone and focus that excitement on your business objectives. Before even beginning on the exciting part, which Daniel talked about as insights, we need to understand what business problem we're trying to solve and how we think a data-led solution will help. What is our strategy for identifying, curating, and using data? Almost every initiative we undertake includes data, and assessing the quality of that data at the beginning of a project can save hours of rework, variations, and changes, thus enabling a better, faster, and more effective outcome. Creating a baseline for data quality allows customers to better manage time, effort, and cost in correcting the data and projects. Companies are also growing the extent to which they're supplementing their own data with external data, and there's real richness available in some specialist external data sources, and we're working with a number of data providers on some of our solutions. So answering these questions at the outset ensures we don't waste time creating a solution that's looking for a problem. It focuses the excitement on the business objectives. And then to counteract the fear side of the coin, we need to focus on governance and stakeholder management. This is where risk expertise really manages with data science skills, since even without a data science background, seasoned risk professionals already know the crucial things that they need to do. Those are identifying resources we currently have in terms of technology and people, and defining the knowledge and technology gap needed to build out the team, and identifying key stakeholders in the business, how they'll be affected, and how they can be brought in to support the change. Understanding these principles gives what is a sizable transformation a fighting chance. It stills the fear you might have about a project. Next slide, please. So on this slide, I'll talk a little about how data preparation fits into the journey. The crucial point to appreciate here is that there's really nothing more than good project management steps on this slide. This being a data project brings one or two new angles, but otherwise this is just an albeit complex transformation project that we're talking about. So if my first slide was all about initial thinking and preparation, this one is all about ramping things up and getting started. Although we're not going to let you loose on the data just yet, I'll be handing over to Danny for that in a moment. There's 4 more steps to complete in preparation first. Defining success criteria is crucial to any project, including deciding when to down tools, since as Daniel mentioned, not every project can be a success. And especially given that we don't yet necessarily know what results we're expecting, we need to focus to ensure a measurement of success can dominate variable outcomes. In the identify stage, we defined the target operating model for our data science team, and this is now the stage at which that team is built. By this point, you can make hires with a clearly defined purpose and set business objectives, and not waste valuable analyst time and motivation getting set up and getting them to define what they need to do. Blending skill sets across actuarial, data science, and customer-facing teams, and identifying data custodians within the business helps firms ensure their teams can act dynamically but within a robust framework. The planning stage covers the acquisition of data, tools, models, and third parties, and answers questions about how we'll use the results of each project. And finally, data governance, ensuring that data is protected, available, accessible, usable, and fit for purpose by data consumers when they need it. This is critical in ensuring companies achieve the anticipated value from data. You don't need to have the world's best data governance before you get started, but you do need to know what you do have and what the gaps are, and making sure you have the right infrastructure around data and recognizing any shortcomings you have before getting started. Assurance and assessment processes for data governance and data protection can provide independent opinion of the controls in place, and we can put in place a roadmap to implement changes that can be used to enhance customer trust, guard against regulatory pressure, and establish frameworks to keep up with the pace of change. Governance is also relevant not just during the project, but ongoing within the business, since wider scale adoption of data science initiatives is causing companies to look at ways of preserving customer trust in an environment where the activity attached to the data is not always that easy to demonstrate. Frameworks for innovation and data ethics are being used to show compliance, intent, and the management of risks by companies in their communication and preservation of trust with their customers. So now for the more exciting part where you get to actually use the data for insights. Over to Danny.
Thanks very much, Lloyd. Next slide, please. So I'm going to be talking a bit about machine learning and why it's so important and why it's considered to be such a revolutionary step forward, especially relative to the actuarial profession, where really we've been a very data-heavy profession for centuries, pretty much. And at the heart of it is the fact that we're trying to use machines to recognize patterns that are useful, and we're very good at that as humans. And the problem is sometimes we're too good at that and we recognize patterns where they aren't, and we have theories in which we believe the world works a certain way, but the only way we can really test our theories is to measure it against reality, and the best representation we have of reality at the moment is the data. So we have tons of data, really astronomical amounts of data. You might have heard statistics along the lines of 90% of the data in the world at the moment was collected in the last 18 months. That is 4 years out of date. It's more than 99% of the data in the world today was collected in the last 18 months. And we're collecting this data exponentially. But really, we do this because we believe that there's a tremendous amount of value in that data, if only we could recognize patterns. And that's where the machines step in, because we're very good at the types of pattern recognition that we do on a day-to-day basis. We're good at image and sound recognition. As actuaries, we're very good at looking at insurance data and the types of things we do on a day-to-day basis. But unfortunately, we simply aren't good at looking at the data the way we normally accumulate it, and that's in databases with millions of lines and thousands of fields, and often in separate tables. We're very bad at that. And that's where we get machines to come in to recognize patterns that are hopefully useful, but also founded in terms of the data. And so what we're trying to do is actually make a lot more use of the data than we have previously. And without belaboring the point, there are actually three main reasons that machine learning is a step change in terms of what we've been doing with data as a profession for a number of years. The one thing is that machine learning handles variable interaction much better than we do as humans, and often a lot better than some of the traditional methods that we've used. So if you look at, say, traditional summary statistics or business intelligence dashboards, where you might summarize our sales by age, gender, and geographical area, that's 3 dimensions. And we're really struggling to come up, at least I am struggling to come up with theories that hold true across those 3 dimensions, whereas machines will happily look at thousands of fields and all of their interactions along various ranges of those variables and come up with patterns that are far beyond human ability to be able to recognize. And that's part of where the value comes in. The second part where it adds value is that it handles imperfect data much better than traditional methods. So provided your data is consistently imperfect, the machine will actually learn valuable patterns of that. And the third reason it does really well is that it has none of the prejudices that we introduce unless we happen to introduce them on purpose. And in particular, we're very biased towards things that we think have a theoretical explanation to explain a feature that we're interested in, and we're very biased against things that we think ought not to explain a particular feature, and we're often wrong in both directions. And I might talk about that a bit more when we get to the case studies. So we're trying to get the machines to bring all of that together and actually learn as autonomously as possible to recognize patterns that we can generate value from. Next slide, please. So the actual process, I don't want to spend too much time on since Lloyd has covered this, but we're really now sitting at the middle stage of those 5 stages where we define the problem and you've done your data collection and collation and you've sorted out your governance. But it's important to note that once you get the data into the machine learning platform, you train it to recognize patterns, that the output of machine learning is just information, and on its own it doesn't do anything. And it's very important this integrates into a business process, because otherwise you just end up with predictions that predict such and such a thing is going to happen, but you won't have any actions in place to be able to take advantage of your foreknowledge. And that's why it's very important to build the AI solution into the business process and make sure that you can actually operationalize the outcomes that you get from the machine learning. And I'll talk about that a bit more in the next slide. But one thing that's very important is the ability to iterate quite quickly. So what you shouldn't be aiming for is getting the perfect model off your first iteration. You should rather be looking to build a quick iteration, see how it works, make a few small changes, and keep on iterating quickly, as opposed to trying to do everything in one step. Next slide, please. The thing that's quite exciting to me as an actuary is the ability to change facts on the ground. So much of the actuarial world has a lot to do with actually having a look at what data is there and reporting on it, and then just building that into long-term assumptions a lot of the time, and hoping that these things stay like that for a long time. Whereas over here, when it comes to machine learning, there's a real opportunity to not just look at what the data is saying, but actually devise interventions that will allow us to change those facts on the ground. And what's wonderful about it is that these are not subtle changes. They're often very, very dramatic changes. And the thing that I love about machine learning, this is now my 20th year in the field of machine learning, and 20 years later, I'm still regularly surprised by how well this works. It's just sometimes leaves your hair standing on end and your jaw hanging slack. So I'm going to go through a couple of real-life insurance examples and case studies that we've performed in the past, just to show you how dramatic this can be. So I'm going to start at the top one, which was an insurance cross-sell example. This was a large multinational insurer. Operations in 3 different continents, and they had a huge portfolio of retirement endowment policies where people were contributing and saving up towards retirement. And when those endowment policies matured, so then they were hoping to convert that lump sum into a retirement annuity to their clients. The problem is that in the one particular portfolio, policyholders could retire anywhere between the ages of 55 and 75, and so getting the timing right was quite a big thing for them in that 20-year window. And what they found was a lot of their customers and policyholders were taking their lump sum and disappearing, and some of them were buying competitors' retirement annuities. So they wanted to be able to offer them their retirement annuities at the right time. And so they built some models, internal models, GLMs, in order to be able to try and work out to whom they should market their retirement annuities and at what time. And it did pretty well. It did increase their conversion, but we built a machine learning model built on exactly the same data that they were using. And bear in mind that insurance companies have a fortune of data. We really have very rich data sets. And we were able to increase their conversion rates by 250%, which means in the end we more than trebled their sales. So it was a dramatic increase in the conversion rate, and that obviously contributes to things like reductions in acquisition costs. And in certain cases in parts of the world, it actually makes certain types of policies possible that weren't possible before, based on the reduction on acquisition cost. On the flip side of the process is retention. So we know all the statistics about how much more valuable a client or a customer is once they've been on your books for a long time. They have an affinity for your product and so on. So what we did was, there was a particular insurer, this was also a multinational insurer, that had quite a bad lapse problem. And what we did was we predicted who was going to cancel their policy 3 months into the future. And we chose 3 months just because we thought that would give them a long enough time in which to intervene. With that particular stage of the process, it was more than 99% accurate. It was quite incredible, actually, that almost to the man, we were able to predict which of the policies were going to cancel. But that didn't save anybody. So this is where the operationalization becomes important. We then devised a series of interventions together with the insurer that they could potentially try to retain these policies. And initially, we just deployed them randomly at the policyholders that we knew were going to leave, and we saw who was retained and who wasn't. And then we built a second stage model that would then stream each of the policyholders who were predicted to leave into one of the interventions. And this resulted in a more than halving of their churn rate, which was consistent and stayed there for more than 3 years. And as a result of that, this led to changes in their long-term assumptions and led to quite a dramatic increase in their embedded value. The next thing that I'd like to talk about is insurance fraud. So this particular case over here was at the claims underwriting stage of the process, and generally what happens is that there's certain flags that get raised, and that leads to increased investigation, or some companies investigate all claims that come their way, and there's often too little resource to be able to do that. So we took a look at which claims have been investigated in the past and which ones turned out to be fraudulent and which ones weren't, and then used that in order to focus the scarce resource of experienced fraud investigators to pick up on particular cases of fraud. And what was great about this is that we actually were able to find twice the amount of fraud, not because we believed there was twice the amount of fraud, but actually just because they were now the fraud investigators were now focusing on less routine cases, and were focusing rather on cases that were actually more likely to be fraud. The cost came down a little bit because one or two of the fraud investigators happened to have resigned or retired during the investigation, but the point is that they were able to pick up more fraud with essentially the same base. When it comes to insurance pricing, when it comes to motor and household and general insurance types of products, so it's very important to get pricing right, because you don't have much time to get to fix things if you get it wrong. And so we know how established this area is in the insurance world, and so we were working with one of the big German insurers that had over 100 million policyholders. With this particular project, we focused on one of their portfolios, which had about 6.5 million policyholders. And with this case over here, again, just trying to accurately predict the risk premium for a particular policyholder, we were looking at trying to predict the frequency and severity for each of the policyholders. And even with a well-established process for pricing, we were able to reduce the error rate on the risk premium, or put differently, improve the accuracy by about 24%, which was a significant improvement overall, even though it was a very well-established risk function. And lastly, with the bottom two, I'm not going to talk about them too much, but what is an important aspect with insurance is where it overlaps with healthcare. And in many cases, particularly when it comes to disability and long-term disability, what you're looking for is an ability to make a decision now about whether a person is going to be disabled for a long time. And even with the best medical insight, we often get that wrong. And what we've done quite a lot of work in the medical field, is we've been able to show that in many cases, we're able to far exceed the best medical knowledge in being able to predict the prognosis for certain conditions, which allows insurers to make better decisions about underwriting, especially at the claim stage. But also quite important in client acquisition is making sure that the underwriting process doesn't scare off policyholders or potential policyholders. And so there's an ability to make these underwriting processes, initial underwriting, much more frictionless by collecting less data, but are still achieving the same type of risk assessment that would be achieved with much more intense medical underwriting or health underwriting at the beginning of the policy. So these are great opportunities to streamline the business and actually add real value to all of the various stages of the policyholder life cycle. I'm now going to hand over to Andy, and he's going to tell you how you can actually get this embedded in a business and overcome a lot of the corporate antibodies that often frustrate these types of products.
Thanks, Danny. And forgive me if my kids come crashing in from school. It's their first day, and I'm half expecting them to emerge at any point. Anyway, it's great that they're there. Let's start. Charles Kettering, American inventor, engineer, and businessman of the first half of the 20th century, once said, "People are very open-minded about new things, as long as they are exactly like the old ones." And, you know, it's always been so. History is marked by the paradox of great leaps forward of innovation, countered by rejection, resistance, and fear from society that longs for continuity and safety. On the whole, people fear innovation over incumbency. Remember the printing press, weaving machines? A fact about the British Industrial Revolution is that more troops were sent to quash the machine-breaking Luddites than were first sent to fight Napoleon. Big data, machine learning, and AI are arguably already in the foothills of their great advance. It is therefore reasonable to expect an inevitable counter-reaction to the likely disruption that will take place. As Mark Twain once wrote, history does not repeat itself, but it rhymes. I bring up the historical context of innovation to underline that invention of new technology is not the difficult part. It is its adoption. Therefore, it's the purpose of this presentation to explore the implementation dilemma, particularly the adoption of machine learning into organizations. In other words, to make sure it's not left on the shelf. To do so, I will take a psychological lens to the question, and in particular examine how leaders can manage the anxiety that is likely to be triggered in the minds of their people. Using a frame of thinking introduced by Freud, I will take the model of an iceberg to reveal some of the organizational opportunities and threats posed by the implementation of machine learning. Next slide, please. Above the waterline, as we all know, there is a small part of the iceberg that we can all see. From an organizational perspective, this is the realm of overt and tangible strategy, structures, and systems. However, below the waterline is the far more influential, intangible, and hidden world of perceptions, beliefs, behaviors, and culture. It is this place where much of what really goes on in a business lurks. Let me give you an example of an unconscious group dynamic bubbling under the surface. Following interviews with customer-facing teams of an insurance client, it emerged that they were frustrated and resentful of their support functions for burdening them with red tape. These teams had decided to placate their anxiety by shooting the messenger rather than working with their support teams to really understand the rationale of the changes being made. This conflict was more about power dynamics than any rational changing of regulatory policy or procedures. So let's examine the emerging themes that may impact the top of the iceberg. Can I have the next part of this slide, please? We know that leveraging data and knowledge can have a transforming effect on businesses. Tesla is not a car manufacturer, but an integrated value chain that exists across battery production, electric motor production, self-driving algorithms to finance and insurance. This is possible because of the fluid and horizontal integration enabled through data. So what impact organizationally will this have on the insurance sector? Well, some insurers I have worked with can be characterized as a collection of small islands made up of distinct teams. Where this structural dynamic has become siloed, they will need to work especially hard to remove ingrained barriers to exploiting data. The composition of jobs, roles, and competencies have already started to change as businesses recruit increasing numbers of data engineers and data scientists. New data analytics and decision-making capabilities are being developed too. Even the organization chart is changing to reflect the power of data. The emergence and increasing status of the Chief Data Officer exemplifies this. Now, let us examine what is going on below the waterline of the iceberg, a space directed far more by perception and emotion. Can I have the next part of this slide too, please? The primary organization dynamic during times of disruption and change is the emotion of loss. Fear of loss can lead people to avoid change brought in by innovation, even if this means foregoing benefits. And yes, this is often driven by perceptions rather than concrete evidence. So why do we focus on loss? Well, firstly, as humans, we are creatures of habit, with much of what we do and decide being made unconsciously. We therefore find it difficult to say goodbye to these patterns of behavior. Indeed, the perception that habits will be destroyed serves to increase the fear of loss even more. Secondly, people perceive that innovation brings risk, whether that be to status, employment, earning potential, etc. We know people have a strong tendency to avoid risks. Prospect theory reveals how losses loom far larger in our mind. Cognitive bias we have for the status quo, and we have a cocktail that makes implementation and adoption of new innovation challenging, costly, and precarious. The good news is that we as humans are programmed with the innate and evolutionary ability to adapt. Indeed, we may find that the global pandemic that we've all experienced will accelerate opportunities and change mindsets to do things differently in more innovative ways. I will therefore explore 3 implementation strategies for us to consider that tackle in particular dynamics that exist below the surface of the iceberg. Can I have the next slide, please? Firstly, the amount of resistance will depend on whether this new innovation is perceived to be competence enhancing or competence destroying. Where it is destroying, it will be perceived as a type of death. Where it is enhancing, it affirms life. Having a motivating and attractive rationale for change is therefore essential. This lays out the adventure, the inspiring purpose, a future to be part of, and a release of new organizational energy. Therefore, what is your why for the changes that are being enabled by data and machine learning, and how will it be life enhancing? Can I have the next part of the slide, please? And actually, can I have the next part of the slide as well, please? Oh dear, maybe you need to go back one. Okay, the second part I want to emphasize is that people will perceive change as loss, and we must develop the skills to better deal with this. Akin to managing grief, people and organizations can use open and honest dialogue and empathy to work their way through changes that may be painful, and to be able to come out the other side renewed and enhanced. An example of this is where we work with an insurance client around what their teams would need to say goodbye to as a consequence of the changes being made. Therefore, much like a wake, people could respect the loss, say their farewells, and move on. Thirdly, and can I have the next part of this slide too, please? Organizations that adopt a learning or growth mindset are better able to deal with the change and adopt new practices more quickly. This reflects their belief that they can continuously learn, adapt, and improve. They have a mindset that sees change as a natural evolution and progression of who they are. They don't worry about looking smart for the sake of it. A cornerstone of this type of learning culture is the concept of psychological safety. This is where we can work without fear and can challenge, question, and express ourselves freely. Therefore, these 3 strategies focused on a positive rationale for change, managing loss, and building a learning culture offer a means for organizations to avoid maladaptive responses that create avoidance and resistance. Thus, adoption can be accelerated. To conclude, innovation throughout history has moved faster than society has been able to cope, which has led to the slow adoption of changes into the mainstream. The fear of uncertainty and complexity that is created is deeply rooted into our psyche. However, we can work on the mind of our organizations to transition faster and to grow and learn in a way that sees machine learning as enhancing rather than threatening. Yes, types of change can often mean loss, but this can be processed in more healthy ways. However, the tension between innovation and organization that has challenged us throughout history remains relevant today as it always has, and will continue to be a dilemma that will trouble our leaders both now and in the future. Thank you. I think that's over to you now, Chris.
Thank you very much, Andy. Very clear and compelling, as you said, examples there about why, how to manage those projects, and really interesting to see about the process of managing loss. It's so we are all slightly reluctant to change. It's a very human nature, but there are obviously ways to overcome that. Okay, let's go over some of your questions. Thank you very much for everyone that's sent in the questions so far. As a reminder, if you just type your questions into the questions tab, we will get around to them as soon as we can. So the first one, lots for you, Danny, I think, here, but hopefully we can get the other people to join in as well. First one I was going to ask you here, you described a insurance retention example in your description of the case studies. What kind of factors did you find to be most significant when trying to predict behavior in insurance retention?
So interesting question. The reality is that with a lot of these machine learning models, they do have a slight, it's a disadvantage of being a bit black boxy, in that it's hard to see which variables are useful. And we do go to the effort of working out which variables are predictive by basically running these models and then leaving out a single variable at a time and seeing what impact that makes on the error rate of the model. But even knowing that a variable is very predictive doesn't tell you in what way it's been predictive. So typically what we found has been very predictive is engagement variables. So has the policyholder made or received communication to or from the insurer within a certain amount of time? Have they obviously filing a claim and having it rejected is a very good predictor of people canceling their policies. The income, the relationship between income and policy increase, at least premium increases, has also been quite predictive. But the reality is that those ones were quite predictive and quite predictably predictive. We kind of knew in advance that they were going to be predictive, so there are no big surprises over there. What was interesting is that there were a lot of variables which you wouldn't have thought would be predictive, but which had small predictability on their own, but in aggregate actually ended up being very predictive. So we looked at stuff like date and timestamps. What times of the day were they communicating? And how long their calls were and things like that. Those ended up actually being very predictive, even though I can't tell you why and how they were predictive.
Thanks, Danny. One perhaps for Lloyd here. Aside from the commercial uses that we've seen presented in the webinar today, have there been any use cases from the capital modelling or reporting space? And if not, what do you think the main barriers for this might be?
Thanks, Chris. So yeah, we focused initially on the commercial use cases simply because having some kind of profit motive makes it much easier to secure buy-in for a project. So a lot of early machine learning use cases in insurance have been quite commercially focused. But there is a much wider range of possible uses, particularly where it comes to modeling more niche risks or risks for which there aren't traditional models. For example, cyber risk models can pull in non-traditional data sets such as Twitter feeds to more accurately predict cyber attacks, sort of which attack is going to be next. We've also worked on modeling on operational risk losses for companies using external data sets. I talked a bit about the real richness available in external data sets, and I think operational risk losses and near misses in particular is one where nobody has a sufficient data set on their own, but there are some pooled data sets that can give real insights about sort of operationally what losses you might be expecting. I think that the barriers that are asked about are fairly similar for any use case, really, other than the addition of you don't have a profit motive with anything that's non-commercially focused, but perhaps the others can add a little more flavour. It's sort of touched on in all of our presentations, that the barriers to implementation.
And just to add to that, if that's okay, because a lot of the machine learning models aren't as explainable as traditional models, that does create a barrier, and especially given that in many cases the role of the actuary is actually to sign off on a particular model. In many cases, the inability to understand some of the models and their predictiveness, why they're so predictive. In fact, in many cases, you hear people talk about the unreasonable predictiveness of these models, can be a barrier in the sense that regulation might prevent it. So not relevant in the insurance space, but for example, in the credit space, there's a requirement when you decline somebody's application for credit to be able to, in many countries, to be able to explain why their application was declined. That's a lot harder. I'm not saying it's impossible, But that's a lot harder with machine learning than with, say, a traditional linear model of sorts. But absolutely, the black box, machine learning has to earn your trust. It has to be able to show that over the long run, it's producing better predictions and generating profit, which is one of the reasons why starting with something that actually generates profit is a very good way to get people to notice that it is worthy of trust if you deploy it right over time.
Yeah, so there's a degree here of say accepting the idea, accepting the technology, then applying it to perhaps areas where there isn't that immediate kind of profit motive. Fantastic. Okay, slightly cheeky question here, I think, but I'm going to try and pose it anyway. So the case study showed impressive success of AI solutions. So surely not all AI solutions are successful. What proportion of AI-based projects are successful?
That's a great question. That's a great question. Sorry, do you mind if I take this one also?
Yeah.
Sorry. It's a great question. And so I spoke at a conference in New York in 2018 where it was on not insurance, but AI applications in banking. And another speaker put up a slide here. It surveyed 2,000 AI projects in the banking field, and he had come up that more than 90% of them had a negative return on investment. So absolutely, that a successful AI project, unfortunately, is the exception at the moment rather than the norm. But to be honest, I think the main reason that this has been the case has been people skipping steps in what Daniel and Lloyd and Andy have been speaking about today. So, for example, making sure that you're solving a problem that's useful and valuable as opposed to just interesting. So many AI projects are cases where people are trying to solve something which is really, really interesting, but doesn't actually translate into profitability for the company. And as a result of that, it will have a negative ROI and therefore won't impress management who's writing big checks for this. And then another big part is the failure to implement properly. And that's also been a big problem where people kind of got the idea that the AI needs to interact properly with people and the business around the AI. And if you don't do that right, your AI just remains a party trick where I can tell you what your card's going to be before you see what your card is, but like David Blaine. It's got, you need to actually be able to, not just to know who's going to leave or who's going to buy your product, but actually set processes in place that will allow you to take advantage of that foreknowledge. So in my experience, those have been the main reasons and for AI projects failing. But even with that in place, absolutely, they're not all perfect and they're not all successful. But if you do this right, you have a very much high proportion of them that are successful and are beneficial.
And Danny, just building on that, I think, it ultimately depends on what's your definition of success, and Lloyd talked a bit about that. If your definition of success is purely around, did you spot useful patterns in the data, then absolutely that's one definition. But ultimately, a much broader definition could be about the extent to which it's helped you achieve your business objectives. And given that not all AI projects can be successful, by definition, innovation doesn't work like that. Even if your project is deemed not to deliver the business outcomes that you originally intended, by following the steps that collectively we've been talking about today, you will learn a huge amount along that journey, which then helps you for the next project, helps you understand where and when you can improve to make that next project even more likely to be successful based on your definition of success.
Andy, I wondered if you had any inputs on this. I did wonder perhaps if in your experience AI projects were perhaps less successful than other kinds of technology change that you've seen. Do people sometimes feel a bit more resistance about human intelligence being replaced with artificial intelligence?
I'm pleased Daniel answered in the way that he did, because I think it's dependent on your definition of success. And I talked about this sort of learning culture that organizations are really going to need to adopt and embrace. And you know what, success can be about learning. And if there are one or two mistakes or areas whereby you can build from, then look, this type of innovation is what's going to become the norm. And I don't, in essence, see much difference between a lot of the technical change that we've seen over the last 20, 30 years and this. I think there is something around the type of individual within an organization that this now is going to impact. Other types of technical innovation have looked at, let's call them lower layers or low levels in an organization. This is going at the heart of knowledge workers potentially. So this is new ground to some extent. I think it's going to be really interesting ground to see how organizations adopt and embrace the concept of how these are supportive to knowledge workers and what I call competency enhancing, rather than the more scary angle of competence destroying or replacement. And I think it will be up to organizations to work out what their rationale will be in their story for how people will react in organizations.
Thank you, Andy. AI is an assistance to us, not a replacement for us. So.
Possibly.
Good. A couple of sort of technical questions, I guess, mainly aimed at Danny, but I'm sure everyone else can weigh in if necessary. Danny, what are the machine learning algorithms used for the case studies discussed? Can you provide any examples?
Yeah, sure. So it's a very interesting point. So there's been a lot of emphasis on deep learning. It's by far the most famous version of machine learning that's spoken about these days, and it certainly has very, very impressive applications. In my experience, though, it's often not the right tool for a lot of the data sets that we're looking at. And I would say that actually only in a minority of cases are we actually using deep learning for the applications and use cases that we've been talking about. So very, very useful ones end up being things like the tree-based methods, whether we're talking about random forests or XGBoost or bootstrap aggregation and so on. So these are very, very useful. Even in Kaggle competitions, it's usually one of those that ends up winning the competition. Again, unreasonably predictive. We don't know why they should be so predictive. But the truth is, actually, GLMs are often very, very useful, even though and these are very well known to the insurance industry. Support vector machines are quite often quoted, though to be honest, I haven't found very many cases where we've used them over other types of methods. And then often you have, I should also mention that each of these things come in 1,000 different flavors. So within these families, there's quite a lot that you can actually do. But the one thing is, just because one has machine learning doesn't mean that it's always the most appropriate tool. In many cases, some of the traditional actuarial methods can achieve results that are as good or approximating as good as some more complicated machine learning methods, in which case there is an advantage to using the simpler method because it's better understood, it's often easier to implement. So but generally we find that the most commonly used method that we've been finding very useful has been one of the tree family methods.
And just to follow up on that quickly, in general, what size of data set is required to be able to use a machine learning solution?
So very glad you asked that. So one of the reasons that we haven't been using neural networks, so one of the things that you see with machine learning methods, that you get diminishing marginal return for extra data. And eventually what you find, so obviously if you have no lines of data and you go up to 1,000 lines of data, so those 1,000 lines of data are very valuable because it's all the information that you have. But going from 1,000 to 2,000, that extra 1,000 will be less valuable than your first 1,000 and so on. And for almost all machine learning methods, what you'll find is that there's almost zero predictive advantage between 1 million lines and 100 million lines of data. By that point, they've plateaued. The one major exception to that has actually been the deep learning methodologies, where they, for some reason, again, nobody really knows why, are still able to exploit these massive data sets. Typically, what we find in an insurance context is that we don't have millions and millions and millions of lines. There are the odd insurers that do have these massive data sets, but by and large, you working with tens of thousands, if not hundreds of thousands of lines, in which case that is plenty. That's more than you need. And so I think it's actually been a bit of a red herring to classify machine learning as one of these big data techniques. It can be, but it also works reasonably well with medium data or smaller data sets. And in fact, there's certain machine learning methods that have been specifically designed to work with especially small data sets. So the smallest I've ever worked with has been a data set of 500 lines. That was actually a medical application. It wasn't an insurance case. Not to say that it was a brilliant model, but the point is it was far better than anything else we could do with that amount of data. So, and that's often something that's overlooked. You don't necessarily want the perfect model. You want to do better than you can otherwise do. And so the smallest we've probably done is about 500, but you typically wouldn't want to do anything with less than, say, 5 to 10,000 lines, and obviously the more the merrier. And by the way, that's just not just in terms of number of examples, but the number of fields you have is also important. So it's not the number of fields being how much you know about each example. And so the richer your data set, obviously the better it is. But if you've got a very short and very thin data set, it's going to be hard to produce something very useful, but not to say it won't be useful. It might be partially useful, but we shouldn't write off partial solutions. So you have much more data than you think you have, I think I should probably say. And there's really an opportunity to exploit it. I can tell you that in having done this with insurance companies for many years, our approach has typically been to go to an insurer and tell us and ask them, can you give us whatever data you have readily at hand? We know there's data throughout the organization that you could give us, but what you have readily at hand is what we want to start with. And on only one occasion in all the years that we've been working, has that not been good enough for something that had to deploy that would add value in the interim? You can obviously iterate and get extra data at a later stage, but you'd be surprised how effective the data you already have would be in these situations.
Danny, thanks. I think Chris might have frozen. I'm not sure, but it looks like he has. So there was another question that I thought was particularly interesting, which was, do insurance data projects benefit customers, or is that only aimed to increase profits? Which is an interesting point. So one of the items on our data journey is around ethics, and as part of that process, that should be leading you to think about obviously the ethical considerations, and ultimately your project should have some benefit for someone or some party. So is that a benefit for your company, for customers, employees, market, or the wider society? And actually we tend to like to focus on what's the benefit ultimately for customers in as many of these projects as possible. Because if you're delivering a better service for your customers, or if you're giving them a better price because you understand them better, then clearly that's better for the customer, with a second order impact that it's better for you as an organization. And obviously these ethical considerations are really important, because if you get these things wrong, then that can impact on your reputation as an organization, and you want to be sort of doing things for good with these projects rather than being seen to be the opposite. So when you're asking these ethical questions, think through what's the specific question that you're trying to answer, and can you answer that question? That's often a good test. So that was that. I don't know whether Lloyd, you've got any further thoughts on that?
Yeah, just briefly on some of the data ethics stuff you talked about. So in my presentation, I referenced frameworks for ethics, and as well as an actuary, I'm a chartered statistician with the Royal Statistical Society, and the RSS and IFOA together have collaborated on the topic of data ethics and have some really useful guidance for how to embed ethics into data science work. As Daniel said, on our data journey, we think about ethics as consideration throughout the entire project cycle. And you can see sort of in the production from the RSS and the IFOA, they have examples of sort of what to do at each stage that really syncs up with our data journey.
Thank you very much, guys, for stepping in there. I'm Ronan McCaughey, Deputy Editor of Insurance CRM. So I'll just continue on. It's been a very insightful chat. One question, if we have time, we've got a question here about AI and how useful it might be for agricultural losses regarding climate change. I don't know if anybody wants to quickly maybe look at that one with climate agriculture.
Danny, is that anything you've seen? I know, Lloyd, you're working on an ESG project and starting to look at climate change modelling. I'm not sure whether agriculture is a part of that as yet.
Sorry, Lloyd, do you want to do that? I'm happy to jump in.
You go first, Danny. I'll add anything about
Sure.
anything to add.
Yeah, sure. Actually, it's quite interesting. Just last year, I happened to bump into this guy who, after some discussion, turns out to be, I knew him from articles. He ended up being the world's foremost authority on using machine learning to forecast weather and climate. He's quite the authority. But absolutely, one of the things that's noteworthy about a lot of the climate forecasting models is that they've all consistently missed the mark, and that tells us that we're not either getting the structure of the complexity right, or alternatively, we're not incorporating enough factors to do the prediction. Or probably both of these things. And so one of the things that they're working on is actually building models, which unfortunately for us in some way they exceed our ability as humans to understand them properly, but which are capturing the unbelievable complexity that goes into the long-term forecasting of climate. And they've already seen substantial improvements in the accuracy of these models. I don't have them readily at hand at the moment, but if you email me, I'd be happy to try you. Where you can actually see that if you're able to incorporate this additional complexity, it can lead to substantial accuracy improvements. And at the moment, they've been just doing it on backtest just because it takes long to wait for the actual experience to emerge. But on backtest, it's been performing really, really well. So there's definitely room for machine learning to help in both forecasting and therefore the management of climate change and how it impacts on the world of insurance.
Yeah, just adding a
thank you.
Sorry,
go ahead.
Add 1 minute of response to that. So as Danny mentioned, so the complexity comes with the number of interrelated factors that you see in climate risk, and models haven't really produced the right numbers going forward. What we're seeing some clients doing is to model the impact on agriculture of climate risk. It's almost like creating an entire scenario generator and then an impact modeler separately from that. I think some of the challenge comes with making sure that the scenario that's generated is internally consistent. As Danny mentioned, the number of interrelating factors that you need to consider, such as carbon pricing, going all the way out to things like coal pricing, potential, we're not just talking about what does a potential temperature increase mean for agriculture. There's so many interrelated factors, and that's where machine learning can really have some impact.
Absolutely, Lloyd. Yep, thank you. I don't think we have any more questions. We've had lots of questions. So thank you to our audience. We've had a fantastic audience worldwide today. But what I would say is, please do email our panel. They'll be, afterwards they'll be more than happy to take any further questions, or you can email them to the Insurance ERM team. We'll pass them on. So first of all, thank you to my editor Chris for an excellent moderation. Just a quick reminder, if you can download the slide deck and handout from the resources tab. We do hope you've enjoyed the session, and we hope you're inspired and better equipped to implement data science projects at your organizations. So finally, my thanks to our great speakers, Daniel, Lloyd, Danny and Andy, and of course our sponsor Crowe. We wish you a very good day and take care, everyone.
Thank you. Thanks for having us.
Thank you. Cheers.